Hi folks, welcome to the series of Wi-Fi 7 put to test. In this series, we are going to talk about various kinds of Wi-Fi 7 features like 4096 QAM, 320 MHz, preamble puncturing, MLO and many more, which add great value to the Wi-Fi performance in real time. We are going to experiment on these kind of features and understand their implementation. So, in today's episode, we are going to talk about 320 MHz channel bandwidth. Basically, 320 MHz channel bandwidth is introduced in Wi-Fi 7 as a key feature to improve the PHY rates. Due to 4096 QAM and 320 MHz channel bandwidth, the PHY rate has been improved up to 46 Gbps in Wi-Fi 7. That adds also NSS 16 by the way. So, if you want to check out the 4096 QAM video, the link is in the description. So why bandwidth plays a significant role in improving the PHY rate? So let's talk about a story. Let us understand about bandwidth using an example. There are a big heap of packets available to courier from one state to another. Bob needs to send all the data via trucks. So he starts looking for a route to send the data. He found a roadway between two destinations. But here is the challenge. Assume if the road is a single lane road, then only one truck can enter the road at an instance and followed by another. As the number of lanes increase, the number of trucks entering the road will increase, due to which there will be a lot of scope to send the heap of packets faster. What if there is an 8-lane road? Then it is going to send so many trucks that most of the packets in the heap will be sent within a short amount of time. So for understanding, we can assume bandwidth as the number of lanes on the road. As the bandwidth increases, more amount of data can be propagated between the transmitter and the receiver. What if there is 16-lane road and a very big heap of packets to get transmitted? So this kind of a situation can be relatable to 320 MHz. So when 320 MHz comes into picture, there is a lot of scope for the data to get transmitted with ease. So let's put 320 MHz to test. To test this scenario, I have used a Wi-Fi 7 access point from TP-Link, which is available in the market for purchase. As a client, I have used BE200 radios and installed them in my traffic generator called LAN4j. So I have done a standalone setup which consists of radios that can operate on Wi-Fi 7 along with the access point. So I am going to run a peak throughput test which involves 4K QAM, which gives us MCS 12 and 13. Along with that, we have two spatial streams for the client as operating NSS. So, with MCS 12 and 13 and two spatial streams, let us see what is the throughput which we can achieve at 320 MHz channel bandwidth. So, let me run the traffic. So, here are my findings, and we can see that we can achieve up to 5 Gbps of real-time throughput. So clearly we can see that the 4K QAM and 320 MHz have added a great value to the PHY and performance improvements in Wi-Fi 7. So how to check if your access point supports 320 MHz channel bandwidth or not? Here are a few beacons of an access point which supports Wi-Fi 7 that broadcasts in 6 GHz. Using Wireshark, we can capture these frames in layer 2. In the tag parameters of a beacon frame, we have EHT capabilities. In the EHT PHY capabilities, we can see the 320 MHz channel bandwidth support in the 0 to 15 bits. As we can see that it is supported, so yes, your access point supports 320 MHz channel width. Similarly, if you want to see the EHT operation of the beacon frame, we can see the control data, which also comprehends that the channel width at which the beacon is broadcasting is 320 MHz. So now, how to check if your client is also supporting 320 MHz channel bandwidth? Let us see that. Here is an association request frame that is captured while a client is getting connected to a Wi-Fi 7 access point in 6 GHz. So, here also we can see the 320 MHz support in EHT capabilities of ASOC request. So, along with that, here are the MCS and NSS sets which describe the MCS and NSS operations at specific bandwidths that can be happening in the 320 MHz channel width. Can we see the bandwidth in QoS frame? Let us see that. In the QoS frames, we have the radio tab header. It has a new field USIG coming into the play when Wi-Fi 7 operations takes place. In the USIG, we can see the common information that has bandwidth data. In this way, we can see the 320 MHz support for your access point as well as the client using the Wireshark captures. So, in the upcoming episodes, we are going to talk about various kinds of Wi-Fi 7 features like MLO, preamble puncturing, and many more. To download the PCAPs in the video, use the link present in the description. This is Vishwaksen signing off from Candela Technologies.